Assalamualaikum warahmatullahi wabarakatuh. In this video, me, Azka, and Fadhil would like to explain about iron's general information, purification methods, and uses. Regarding the chemical properties of iron, it's in group 8b in the old naming system and group 8 in the new naming system. So not to confuse this group 8b with 8a, which is the noble gas group. So group 8 in the new naming system is actually out of 18. So in the new system, the noble gas group would be in group 18 instead of 8. Right, so this is just to distinguish iron, which is in group 8b, from the noble gases in group 8a. Iron's period is in period 4. Its atomic number is 26 and its symbol is Fe. Its atomic weight is 55.845 grams per mole. Its electronic configuration is the same for argon in the first part, but adding these two shells, so argon and then 3d6 and 4s2. Iron's electron negativity is 1.83 in the Pauling scale. Iron can react with water vapor and produce hydrogen gas, and iron is non-toxic. Iron has multiple oxidation numbers, but its most stable forms are +2 and +3. Iron is a transition metal and it can form ionic bonds with nonmetals, such as in this compound, which is iron 3 oxide, and metallic bonds with other metals. Iron can also act as a central metal ion in coordination complexes because it is a transition metal. About iron's physical properties, its melting point is 1,538 degrees Celsius. Its boiling point is 3,000 degrees Celsius. Its specific gravity, which is the ratio between the density of a substance, which is iron in this case, and that of water, is 7.86 at 20 degrees Celsius. There is no unit for specific gravity because it is a ratio between the two densities. Iron's color is silver gray. Iron is malleable, which can easily be cut, and iron's magnetic property is ferromagnetic. So ferromagnetic means that iron is affected strongly by the magnetic fields. So diamagnetic means that an element is not affected by magnetic fields, and paramagnetic elements are affected but weakly. And actually, the word ferro here is derived from this, which is iron. So it's kind of obvious that iron is strongly attracted to magnets. Iron is conductive. Iron is the most stable element in the universe. It has the highest binding energy per nucleon, which is the energy needed to separate the contents of the nucleus divided by the number of protons and neutrons. So, and the value of the binding energy per nucleon of iron is 8.8 mega electron volts. So, other elements have the tendency to undergo fusion in the case of smaller elements in regards to their atomic radius, and bigger elements, they have the tendency to go fission because they want to attain the iron's property of being the most stable element in the universe. Now I would like to begin talking about the purification processes of iron. So iron, first of all, can be obtained through mining. The ore is mined from large open pits by progressive extraction along steps or benches. The benches provide access to progressively deeper ores as upper level ores are removed. After the soil and overlying rock are cleared, the ore is drilled and blasted. Now, actually, the purification of iron doesn't end here because the iron here is still impure, and iron needs to go to the blast furnace, and lots of chemicals are involved. Now, I'd like to give Fadhil Rafah the chance to speak and to explain the rest of the slides.
Okay, thank you, Azka. And now I would like to explain the iron purification through the blast furnace. So firstly, blast furnace is a huge container that is used to purify iron from iron ore. So as you can see in the diagram, that is the blast furnace, and below the diagram, there are the raw materials for the reaction. The raw materials are iron ore, hematite, coke, limestone, and air. Each material has its own compounds and function. First is the iron ore. It contains iron 3 oxide. And function, the iron ore is a compound that the iron is extracted from. So the iron ore contains iron, which is the product of the blast furnace. Then there is coke, which contains carbon, and it is used as a fuel and reacts to form carbon monoxide, which is needed to reduce the iron 3 oxide. Next, there is limestone, which contains calcium carbonate, and it helps to remove acidic impurities from the iron by reacting with them to form molten slag. These molten slag flows, as you can see in the diagram, in the left bottom corner. And lastly, there's air, which contains oxygen, and it provides oxygen to allow the coke to burn and so produces heat. So those are the raw materials and the functions. And now to the process of the iron purification. So the first step, hot air, oxygen, reacts with the coke or carbon to produce carbon dioxide and heat energy to heat up the furnace. So as you can see, there's the reaction, the carbon with the O2, the oxygen, and then step 2, more coke is added to the furnace and reduces the carbon dioxide into carbon monoxide, a good reducing agent. Step 3, iron 3 oxide is reduced. And in this reaction, iron 3 oxide is reduced to iron and the carbon is oxidized to carbon dioxide. And in this blast furnace, it is so hot that the carbon monoxide can be used in place of carbon to reduce the iron 3 oxide. And so that is it for the blast furnace. And now another method of obtaining iron is through electrolysis. So yes, elemental iron can also be acquired by means of electrolysis. Aqueous iron 3 oxide can be electrolyzed such that the iron 3 cation is reduced to solid iron that is liberated at the cathode. And now the reaction, larutan iron 3 oxide or aqueous iron 3 oxide with the platinum or platina electrode. So as you can see, the cathode, the iron is reduced, and in the anode the oxygen is oxidized, and it forms the reaction. And aqueous iron is able to receive electrons to become solid at the cathode, as iron is to the right of water in the galvanic series below. And so those are the methods of obtaining iron, and now moving on to the uses. So iron has various uses, but primarily it is used to fulfill dietary needs and make metallic compounds. So iron is very crucial for our blood, as we know, such as in the production of red blood cells, the production of hemoglobin, preventing iron deficiency, used to carry oxygen throughout the body, which is through the blood, and is also a vital mineral for humans, and is also needed by the immune system and need to make new cells in organisms. And now to the use of iron in making metallic compounds. So in steel manufacturing, iron is a very crucial element in manufacturing of steel, in making machine parts in tools, vehicles, bicycle chains, transmission tower or electricity pylons, and also cooking pans. So those are the uses of iron, and now here are the sources of information that we took for the images and content in this presentation. And so that is it from me, Fadhil, and Azka for our presentation about iron. We apologize if there are any mistakes. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.